So welcome again. Thank you very much for joining our today's session. My name is Jana. I'm the product marketing specialist here at Innovatrics, and I will be your host for today. I'm especially looking forward to our today's session because we're going to talk about our latest release, the Innovatrics ABIS, the 9th generation of it, which we are very proud of. And which is powered by the world's best performing algorithms. But before we jump into it, let me tell you a couple of sentences about our company. First, okay, you should see the next slide. Yeah, okay, here we go. So Innovatrics is an independent provider of biometric solutions for governments and enterprises. And we are based in Slovakia, in Bratislava, and we've been developing our own biometric algorithms since 2004. So for more than 20 years now, we have delivered more than 500 projects in more than 80 countries around the world. Before we start, let's have some practical information first. So today's session will be divided into two parts. The first part will take approximately 20 minutes. It will be delivered by my colleague sitting next to me, which I'm going to introduce shortly. And after the presentation and live demo, there will be a Q&A session. Feel free to ask your questions during the webinar anytime. For that, please use the Q&A function, as you can see highlighted on the screen. And don't worry about missing any details because we will be sharing the recording with you shortly after the webinar is concluded. So now the speakers for today, sitting next to me is Matúš Kapusta, ABIS Business Unit Director, and next to him, Miška Franková, the business consultant of ABIS team. Well, I hope you're going to enjoy today's session, and Matúš, the floor is yours.
Thank you for a nice introduction. Good morning, good afternoon, good evening, everyone. Before I will jump to what's new in ABIS 9, I would like to do a short recap of ABIS and Innovatrics history, because ABIS and Innovatrics it's a very tight connection. So the Innovatrics company is already 20 years on the market, and it all started with fingerprint algorithm in 2004, when our founder and CEO till today, Jan Gunter, created a new fingerprint algorithm. Back in 2008, we have released first ABIS. At the time, it was a software which was able to do server-side identification. 2 years later, we have introduced a cluster version of that software with high availability. Afterwards, we have added that time very modern MQ interface and fast identification, and also interface for fingerprint adjudication. 2016, we did a big improvement with ABIS 4, where we have introduced a new business module, which allow our users to do customizable workflows as well as custom record structure. This was also a first web-based interface for ABIS. 2017, our ABIS became ABIS. With the version 5, we have introduced facial identification and also a new web-based enrollment module. The year after, we have added iris identification, and we have started in the domain of criminal investigation with latent fingerprint editor. 2020, we have launched ABIS 7 with active deployment and palm print matching. We have also developed our first complete solution for a specific domain, which was that time voter registration, including mobile enrollment and voters list generation. In 2021, after 9 years, we have introduced now modern REST API, and we have also introduced new solution for criminal investigation, including face and video identification. And today, we are coming with the new version of ABIS, which is ABIS 9. It contains a lot of upgrades. It contains new fingerprint identification algorithm, new modules for DNA, and some other improvements that we will demonstrate during this webinar. Just a short recap, what is ABIS 9? Rather than ABIS 9 as a single product, we consider this to be an ABIS 9 product family. Because inside we have ABIS 9, which is actually a matching cluster with REST API, but we have plenty of modules which will allow you to tailor the ABIS for your specific use case. For example, you can use ABIS for criminal investigation. In such a case, you can use our modules for criminal enrollment, case management, or video investigation. Then we have a solution for travel and border. You can use our application for mobile enrollment, for example, for e-visa, or you can use a fast real-time identification algorithm for border control. Then we have workflow modules, which will help you with identity management for civil identification or remote identification for digital ID. And then we have also a complete solution of software for biometric voter registration. I would like to start about what's new inside. So inside we have an API and matching cluster. We have developed after several years completely new fingerprint identification algorithms. So now we have two different algorithms. One is super fast print identification for civil identification, and the second is latent print identification. We have also developed the next generation of iris identification, and we have added new modality, DNA. Before I will show you how fast we are able to match fingerprints, I would like to explain a little bit the principle behind it. So before we can identify or verify fingerprints, we have to do a fingerprint template extraction. So we take the fingerprint image, we extract so-called minutia points, we extract pattern information, and we are also extracting something which we call fast record. That's actually the secret sauce of Innovatrics, and there is a record which allows us to do super fast fingerprint identification. So what's the improvement between the two versions? We already had fast records in ABIS 8, and in ABIS 9, we have completely new version of our fast record. What does it mean in real life? So the fast record in ABIS 9 was able to deliver 2.5 million comparisons per second per core, which is approximately 120 million per server. For this benchmark, we have been using the new AMD EPYC 4th generation CPU with 48 cores each. With ABIS 9, we are 8 times faster. So we are able to do 20 million per second per core, or 960 million per server. In reality, we have measured more than 1 billion, something like 1.2 billion comparisons per server, but we would like to have here some safety margins, so you can use this number directly for your sizing. What about the memory footprint? Another parameter which is very important for hardware sizing. So with ABIS 8, we have to keep the whole template in the memory. So for 10 fingerprints, it was 25 kilobytes. With the new one, it's only 6.5 kilobytes. Why this is the case? It's 4 times smaller, because we don't have to keep all the information, just the fast records. We use the whole templates directly from the database only to verify the top matching candidates. And what about the extraction time? Yeah, there is a catch here, because it was 80 milliseconds in a version 8, but now it's 320 milliseconds. Because the fast record is so much more sophisticated, it takes more time to extract this information. What does it mean for a real-life use case? Let's consider this scenario. So we have a gallery size of 40 million records for a border control use case. We have for 2 enrollments, so 10 fingerprints per record, and we have 24 border crossings per second in a peak period, or 1,500 per minute, which is pretty busy border. And we would like to have a server redundancy. What does it mean for our sizing? We have to do approximately 240 extractions per second. This is easy because we have 24 border crossings and every person has 10 prints, so it's 240 per second. But we have to do 9.6 billion, so almost 10 billion fingerprint comparisons per second. Why that many? Because we have 40 million records, which means 400 million fingerprints, and we have to compare all of them with those 24 people crossing the border every single second. So we need to design our cluster to be able to perform 9.6 billion comparisons per second. What does it mean for the sizing? Okay, so yeah, we need 2 times more extraction servers. So instead of 1 server, which will work only on 30% load with ABIS 8, we will need 2 servers with ABIS 9. But what about matching servers? Instead of 48, we will need just 6 matching servers, so 8 times less. But of course, the memory consumption per server will be slightly higher because we still have to accommodate all 40 million users on 6 servers instead of 48. So we will have to use 768 gigabytes per server. But overall memory consumption is 3 times less. So instead of 19 terabytes of memory, we will need only 6.2 terabytes. This is a significant cost improvement for your projects. And it's not only about the cost of the hardware, but also related maintenance and installation effort. But okay, let's have a look on accuracy. We have a fast identification, but is it accurate? So we have performed some accurate tests on our internal dataset. This dataset of 10 million template records, we have measured false negative identification rate, which corresponds to a real-life scenario. This dataset is pretty difficult. It contains a combination of civil, criminal, children, fingerprints, and also fingerprints captured from mobile phones. So the accuracy that we have measured with the fast algorithm in ABIS 8 was 1.9%. The false negative identification rate with a slow algorithm using the minutia points instead of fast record was 0.38%. With ABIS 9, which is 8 times faster than the fast algorithm in ABIS 8, we have measured 0.12%, so it's more accurate than the slow one in the previous version of ABIS. What about the forced lap identification, which is, for example, used or will be used one day in an entry-exit system in European border? With the slow algorithm, we have achieved 1.8% accuracy. With the new one, which is much faster, the error rate was 0.83. So that's it for the civil temporary identification, but we also have a new algorithm for latent fingerprint identification. In this scenario, we are not using fast record, but we are using that part where minutia and pattern informations are stored. Last year, we have successfully submitted to NIST ELFT benchmark, and the recent submission is ranked among top 3 submissions in accuracy, rank-based search in NIST ELFT nutrition report. You can see the screenshot taken directly from the NIST nutrition report. Our new algorithm will allow you also to define different speed levels. So you can launch super fast identification. Of course, it's slower than for handprint identification, but you can have a response within a few seconds, or also to search with a super accurate, long-lasting identification that can last for several hours. Also, we are covering all use cases related to latent fingerprints, so latent to rolled, latent to plain, latent to palm print, or latent to latent. And also, our new latent or fingerprint template, which is used for latent print identification, still has a small memory footprint of a few kilobytes per fingerprint. We did not only improve our fingerprint matching, but also iris. As you can see in NIST iris benchmark, if you will list top iris algorithms by accuracy, among the top 5, 3 submissions are from Innovatrics. We have highlighted our submissions with the focus on template size and search time. Why we did this is that we would like to explain that we have been using here real-life speed and accuracy. If you can see the rank 5, which is our least accurate algorithm, it's still accurate enough, and the template size is only 561 bytes, which is 100 times less than the most accurate algorithm, and still 10 times less than any other algorithm among top 10. Also, the search time is 0.14 seconds, which is 10 times less than the second, 20 times less than the second one in the top 10. So you can really use this algorithm for your real-life use case, such as border control. The real-life matching speed is approximately 10 million per second per core. And also extraction is pretty fast, and template size is around 500 bytes. We plan to more submissions for IREX this year, so we still believe that we can further improve the accuracy of our IRIS algorithm. Another addition to ABIS biometric family is DNA. In this use case, we use so-called STR analysis, which is industry standard for DNA identification. It is produced either by lab DNA analysis or rapid DNA analysis developed by some vendors using their compact machines that can do DNA analysis within, let's say, 90 minutes. What is our implementation in ABIS is that you can attach DNA information to applicant record using standard API similar to iris, fingerprint, or face, and you can use it, for example, for DNA identification or kinship analysis. So that's all for matching cluster. And I would like to introduce also some new features related to our software modules. I would like to start with the new enrollment software. As we have mentioned, we have a fully web-based solution for civil and criminal identification. And we did not only introduce new modernized user interface, but also we have completely reworked the technology behind. So now new enrollment is much more comfortable and intuitive than the previous one, and is also has better performance. It's much more stable. We also have an application which can be used on any Android device, so handheld or mobile enrollment station. Innovatrics also provide a solution for self-enrollment. You can use this one, for example, for e-visa. We are using features from DOT product, which is another product provided by Innovatrics, and we use OCR or liveness check here. You can use this for digital ID verification or e-visa application. And of course, we also provide complete criminal suspect booking, so we can enroll fingerprint card or live film or roll prints, mugshots, scars, marks, and tattoos. If for some reason you prefer to develop your own enrollment, instead of using 3 SDKs as we used to provide it in the past for segmentation, identification, and face. Now we have a new product which is called Enrollment SDK. It combines all Innovatrics SDK, which can be used for enrollment, into a single simple product with a unified API, and it allows you to do an easy integration of various functions for your enrollment software. So you can do facial portrait, iCal quality check, NFIQ, or local verification or identification. What is the difference from the previous version is now it can be deployed as a service. So in case some function will crash, for example, the whole application will not crash. So only the service will crash and you can just restart it. It also allows you to combine 32-bit and 64-bit architecture. Our SDK is running on Windows, Linux, and Android. A new feature which was developed for criminal investigation is consent identification. When you have a latent fingerprint and you are trying to identify it, you can search ABIS gallery. So it's so-called open set identification. So in this model use case, we can search in civil or criminal gallery. But imagine that you already have a criminal case and you have some people who are related to that case. So you just want to compare your latent fingerprints to those people who are related to the case. You don't want to search the whole gallery of millions of people because it takes time and it's also not that accurate as a one-to-few search. So you can define your own so-called closed sets or case galleries, for example, suspects or victims or people who are working on a crime scene, and search only those galleries. It can save your time and you can get to the result in a more straightforward way. Another improvement in ABIS 9 is completely reworked UI. After 5 years, when we last switched from white to black interface, now we have introduced a more modern UI. We have changed the system color, which used to be red is now blue, and we use the red color as a semantic color to indicate that something is wrong. For example, error messages or low quality fingerprint images. We have also introduced a left navigation pane for easy navigation in applicant detail, for example, in this use case. We did a significant effort and a lot of testing with users so that the new interface is more intuitive and easy to use. And that's all from my side. And now I would like to ask my colleague Michaela to do a live demo. In this demo, we will show you how to do the enrollment, how we will process this enrollment on the central site with our workflow module and education tool, and we will also show you how we will do the investigation.
Fantastic, thank you very much. Hello, everyone. So today I will guide you through 3 different scenarios. We will start at a police station by enrolling suspect number 5 in our latest case. Excuse me. Sorry. So, as you can see on the screen, we offer different types of enrollment. It is still quite common to use a paper-based enrollment using temperance cards and ink, as the hardware for the live enrollment is pretty expensive. Our enrollment has a hybrid model, so we can either use a live enrollment and use capturing by camera, or we can upload the photos. So in this case, I will upload a photo, and as you can see, we are calculating the eCal parameters as well. You can see the environmental parameters on the left and the facial on the right. We move on to the card. In this case, we are using FD258 card, but we are able to integrate any other type of criminal or civil card. As you can shortly see, the result is exactly the same as with the live enrollment, and the operator can see straight away the qualities for the individual fingerprints. We are calculating the NFIQ1 and 2 scores recommended by NIST, as well as our internal scores, placement score and a quality score. As Matusz already mentioned, throughout the ABIS, we use the semantic colors. There are colors which make sense, so red is for bad and the green is for good. So let me just finish the enrollment. So this can all be adjusted according to the needs of the individual law enforcement agencies. We can quickly run through the overview, and if necessary, we can either retake or restart the whole process. I will submit the enrollment and we will upload the enrollment. And here, the work of the police officer at the booking station is finished. So let me go to our next scenario. Okay, we just need to wait a bit. So let's go to the next scenario. And thanks to our web interface, all we need is just the web browser and user account in order to upload the data. Thus, we can move on to the scenario 2, where the enrollment was uploaded into the central biometric database. In the second scenario, in the second scenario, the admin will be notified that a new biometric subject was added and can proceed with analyzing the data. All the captured data are in the profile, as well as the original temprint card as the single source of truth. We can also see that our new biometric subject is a duplicate. So this means that that person was already previously enrolled, and it can either mean it's a recidivist, because as you know, many criminals are booked more than once per lifetime. So let's have a look and resolve the issue. So we can see the overall score is very high. And for the overall score is very high. And we can see also the scores for the individual data, either for the fingerprints, irises, or for the face. In this case, we can have a look at the face and compare the face and use one of our facial tools for the comparison. So either we can do split or face. And if the score is lower, there is always a possibility of manual comparison in order to help to achieve the final decision, whether it is the same person or not. In this case, we can successfully conclude it is the same person. And because we would like to keep the latest and most recent data, we will update the profile. So I will submit. And this basically concludes the work of the administrator at the central registry. So our next scenario, in as examiner. So we will move on to the third scenario and delve deeper into the forensic investigation. Forensic examiner has a fresh case and got info that a new suspect was booked. So in investigations, it is very common practice to create a small galleries within the case. So in the small galleries, we can add persons related to the case, such as witnesses, scene of crime officers, victims, for the exclusion purposes. And also we are able to create a separate gallery for the suspects. So we can see we have 4 suspects here. We got the info that we have a 5th new suspect, and we can add this suspect to the gallery in order to help with the investigation, make it a bit more faster and also accurate. So I will continue with analyzing the latent print exhibit number 3, and which didn't yield any results up until now. So we will try once more. So we will apply the mask, invert the colors, and detect the minutia points. So the reason why we inverted the colors is we wanted the ridges to appear in black in order to help with the minutia detection. So after saving the latent, we will move on to the search. We can either search within the central database, as I'll show you in a second, but this can take really longer time because in the central ABIS database, that can contain millions of records. So we will search only within the case gallery. So we will search only within the suspect gallery. And we can see we do have a hit. And this is pretty accurate. There is a matching score of 77. You can see we have 22 minutia points. And we can see the match was found on the 4th slot. But we do have same cases applied to our right index, which is rolled, and to the right index, which is plain, which is just a little bit lower score. So, and this concludes the work of the forensic examiner. And this doesn't mean that our suspect is guilty. So the investigation continues. And I will leave the rest of the story up to your imagination. Thank you for letting me guide you through the scenario of the demo of the ABIS 9. And I will hand the word over to Matusz.
Thank you very much, Miška.
Thank you.
Before Matusz continues, let me switch the slides. Okay. Oh, there we go.
So, what's next? We would like to share some information about what we are working on right now. So this year, we would like to launch a new solution which will allow you to enroll and analyze 1000 DPI fingerprints. We will be able to offer you a new interface to export NIST files with the support of EBDS standard from API. We would like to introduce also some workflows in improvement, including ACEV support for case management and criminal investigation. We would like to improve our face and video identification. We are preparing a submission for face in video NIST benchmark. We plan to launch a new, more intuitive administration interface with reworked users, roles, and rights. And also, we would like to speed up our iris and face matching to twice to 20 million per second per core, same speed as we have for fingerprints. Of course, we are also working on other new features, but this is just a short summary what's on the roadmap till the end of the year.
So definitely another interesting things coming up. Okay, thank you very much, guys, for an interesting presentation. I hope you all enjoyed it the same way I did. And now is the time for the Q&A session. As promised, I can see the questions are coming in, so we can start to take one by one and answer them, right? Okay, so the first question from Oscar. Hello, I just want to know if it is possible to try the new API. I saw a slide with the gRPC integration over REST API in ABIS 8.
Okay, so there are two things. There is a REST API for ABIS 9, which is more or less an evolution of the API from ABIS 8. And there is a new gRPC interface which is used inside enrollment SDK. But when you will integrate the enrollment SDK into your application, you will use it as a standard library, and you will get together with the enrollment SDK, you will also get the samples which will guide you through the integration process.
Okay. The next questions goes back to the border control use case you were showing. So during the border control case with 40 million, if extraction time is 4 times, then how server requires on 2 times? Okay.
Actually, I have briefly mentioned it during my presentation, but we have been using for our sample server a very quite powerful machine with 48 cores. So 2 CPUs with 48 core, 24 cores each. And for the scenario with ABIS 8, probably we will use only 30% of those cores, or maybe, for ABIS 9, it will be 4 times more, so we will need 2 servers.
Okay.
But technically, you could use a single CPU server for extraction with ABIS 9 for the same use case.
Next question, any experience on matching fingerprints from children under 5 years?
Oh, yeah. So if it's on 4.5, it's not that difficult. But if we are talking about the newborn, then it's quite complicated. And it also depends on the scanner that you are using. So if you have a resolution which is high for small children, it probably will work, but we don't have the real-life experience with newborns. So you have to do the proof of concept and feasibility study to check whether it works.
Next up is Mike. Can you create galleries via the API, and can these be 10-print galleries, not just latent? And also via the API create a gallery just for photos / face.
Yes, you can do this, and you can create any kind of gallery, and also for face or iris or different civil use cases. And this feature was already in ABIS 8. What we have in ABIS 9, it's just the closed set identification, so case galleries for ABIS 9. Right now, they can be only created by the operator who is working on that case. But the general galleries can be created also by API.
Does ABIS 9 allow for using Dockers in a public cloud?
Good question. I would say not yet. It's something we are working on right now, so it will be also launched in 2024. We have a partial support, but we can provide more details via my email or directly.
Okay, another question. Can you please provide a brief on technologies used?
Yes, so for the fast record, we are using deep neural networks, so machine learning, and thanks to the advance, we can develop new models which are very accurate and also fast at the same time. This is thanks to progress in AI. And also, of course, the skills of our R&D team and our experience in the domain that we gathered for 20 years.
Exactly. I just wanted to emphasize our R&D. Yeah. Another question: is deployment architecture differs from ABIS 8?
This is a similar question. Yes, it's not that different yet, but we are working on the change from the ABIS 8-like deployment to a new Docker and Kubernetes deployment.
Well, and that's the end of the questions for now. So if you have any, please ask them now. Otherwise, we'll be concluding this session shortly. Yeah, here you can see, there's another one. Okay, from Robert. Hi, I am a big fan of your team. Thank you very much, Robert. With the ABIS 9, your structure went from separate modules to the new one, integrated module. How is the pricing determined now if you need just a subset of the functionality for a certain product and wish to implement your own solution for the rest?
Actually, the pricing was not changed. So it's the same as it used to be for ABIS 8. So you can pick modalities and module that you need for your use case, and the rest you can do it on your own. Same as for enrollment, you can either use nothing at all, or use our enrollment SDK, or use our complete enrollment solution for your use case. And based on your preference, we will offer you a custom pricing.
If you need to follow up on any of those your questions, you can see the contact details on the screen now. So feel free to reach out, even via email, or yeah, that's probably the best. The next question, Mishka, I can see this probably your friends from the University in India. So hi team Innovatrics, thanks to Cameron and Michaela for this opportunity. Mishka and team, when are you launching ABIS of the 10th generation?
Well, I will let Matthew answer this.
And
and I'll answer the next question.
Okay, cool.
So we will see. It's not yet on the roadmap. It will be probably related to the cloud. But now we are focusing on ABIS version 9 and to make it the best ABIS we ever did.
Yeah, perfect.
And as for the second question, we would love to make a webinar or maybe some kind of workshop for you online anytime. So I'll definitely get in touch with you via email.
Cool. All right. So Robert thanks us for the reply. Majesh, if I pronounce it well, says great progress to our team. Thank you very much. Another question from Lionel. Have you developed identification of a child through footprint scanning technology?
No, or actually we can say not yet. But if you can, we are willing, or we are open to cooperation, but we don't have the data for this use case. So if we have enough data, we think that in cooperation with the solution provider, we have the capabilities to develop such an algorithm, but we don't have the data as of now, so it's difficult to do this. And it's quite complicated to collect the data on our own, but we are open to cooperation on such a use case.
Yeah. All right. And Gary says, very informative presentation and demonstration. Thank you. Thank you too, Gary. We're glad that you all hopefully enjoyed this session. If you have any more questions, please ask them now, and if not, we will be...
You can also reach us later on
definitely.
Our emails, and we'll gladly reply or answer later.
Yeah, definitely. Okay, so it looks like there are no more questions. So thank you very much again for joining. Thank you to my colleagues for delivering this interesting presentation, and we hope to see you next time. And as promised, shortly after this webinar, we will be sharing the recording of this session We will be sharing the recording of this session with all of you. Robert says that's why we're all laughing. I wish I was a criminal investigator now. Thank you very much, Robert. Okay. Thank you very much, people.
Thank you.
Bye-bye.
Have
Bye.
a nice rest of the day. Bye.